All right, this is the last lesson for Chapter 9. This is 9.8 Pythagorean Theorem with spatial figures. So let's just get started. What are prehistoric monsters called when they sleep? So what do you call a prehistoric monster when it sleeps? A dinosaur. Dinosaur. You get it? Uh, that was a little science humor there. All right, so first off, we're looking at two things. We're going to be looking at rectangular solids and then regular square pyramids. So in a rectangular solid, when we look at that, let's name it. So first off, what do we have? We can name it by its faces. Well, first off, you should see 6 faces. You should see that E, H, A, B is a face here. So we got one face there, we got a face off on the side, face in the back, face on the other side, face on the top, face on the bottom. We've already talked about this. Edges are when the faces connect, so like something like HB would be an edge, GC, FG, EH, AB, and so on. If you're looking for diagonals, diagonals are like FB here, or AG, or EC, okay, things like that. And then finally, if you want base diagonals, find one of the bases. So something like you see down here, DB would be a base diagonal. AC down here would be a base diagonal. So you could also say EG is a base diagonal, if that's what you were looking for. Over in the regular square pyramid, what do we notice? We notice that the base is a square, so we know all the sides. So we can name the base. There's only one of them, B, C, D, E. All right, the vertex, name a vertex. Vertex is where any of the pieces connect. So the major vertex is A. You know, it's called the apex. It's the highest point of it. Good to know. If you want an altitude, the altitude is the line in the center of the pyramid. So AF is the only possible choice here. If you want a lateral edge connects the triangles to them. If you haven't noticed, that's what makes the pyramid. So like AD would be a lateral edge, AC, and so on. And then a slant height is a height that is slanting to one of the faces. So AH right here would be one of them. How many can there be? Well, one there, one in this one in the back one in the one on the left, so you could also have 4, just like you could have 4 edges. All right, now knowing that, let's jump right into ours. Note, here's another nice note. Note a cube is a rectangle solid where all the edges are congruent. So if you get something like that, it's nice because it's made of squares and then all the edges are congruent. So in this first one here, we don't know where the sides go, but just go with it. With what do you think the sides look like? So here's 3, here's 5, here's 12. So the height is 3s, the width is 5s, the length are 12s. Doesn't really matter. We want the diagonal, so we want FB, the diagonal to the figure. Well, first off, we only know that since it's a rectangular solid, we can get a right triangle right there. Well, for that blue right triangle, we know that this side is 3. This is the side we want. So maybe we can get this side down here first. And to be able to do that, if I switch colors, you will notice down here is a right triangle with the right angle in the corner because they're rectangles. That right triangle, check it out, has a side of 5 and a side of 12. Well, we can find this side right here, which is our question mark in the blue one, and we could do Pythagorean theorem. Or we know this is a 5, 12, 13 right triangle. So right off the bat, this side is 13. So now we can plug it in here. Now what do we know? Now we can do our magic over here of what we need. And we can end with our answer of Pythagorean theorem of saying 13, or x squared, is equal to 3 squared plus 13 squared. And we have 9 plus 13 squared, 169, equaling x squared. Add them up. X squared is equal to 178. Root it. And the square root of 178 doesn't. So the diagonal, which is FB in this case, is the square root of 178. Great job. So it doesn't really matter where the 3, 5, and 12 go, or whatever three numbers you're going to get on the test, because you're going to basically do Pythagorean theorem twice. If you don't know this question, you are going to get it wrong, and all it is Pythagorean theorem twice. Moving on to example 2. Given a regular square pyramid with a perimeter of base equals 40. So the perimeter is equal to 40. Well, that helps, because how many sides does the base have? 4, giving you 10, 10, 10, and another 10. Because you know, when you divide by 4, you get 10. Okay, the altitude is 12. Well, we know that's AF right there. We want to find the slant height and the lateral edge. Okay, well, we can see that there's this blue right triangle. So let's draw that out. We know the altitude is 12. It's a right triangle. And we want to find the slant height, which we'll call x. So we need this side before we can do Pythagorean theorem. But wait, if this is 10, this part has to be right in the middle because it's that square. And we know that that square is perfect, just like me. So if that's 10, each side is 5. Which now again we're seeing Pythagorean theorem, or no, this is a 5, 12, 13. So AH, which is our slant height, is going to be 13. Switching colors again. If we want a lateral edge, we're looking more at a triangle like this. Okay, we just learned that this side is 13. So if we were to draw this right triangle of AHC, if you notice it, AH is 13. This bottom piece is 5. There's the right angle. So most are going to be like, oh, awesome, 12. And then Mr. B is going to be like, oh, you got it wrong, because it's not, the 12 cannot be the side that's the hypotenuse that 13 needs to. So what do you need to do? To get this piece, you need to do Pythagorean theorem. Alright, x squared is equal to, you get 169 plus 25, equaling 194. Root it. X squared is equal to the square root of 194. And that is our lateral edge. Good stuff, right? I hope so. So, finishing it up, given the regular square pyramid, we have a slant height of 8, so we know that AH is 8. And then we have angle AHF, so this angle right here is 60. Well, why do you think I gave you that this time? Because now you're looking at it, that this triangle is, that's right, a 30, 60, 90. Superimpose the triangle over x, x root 3, 2x. So we know 8 is equal to 2x. Divided by 2, x is 4. So 4 goes down here. 4 root 3 goes here. So we just learned that the altitude to the figure is 4 root 3. So we lock in altitude equaling 4 root 3. We also learned that this piece down here is 4. Which then that helps us because now we can do the lateral edge for this triangle here, because we learned that that's 4. This has to be 4 because this whole side length is 8. And so now looking at that right triangle, we have this side of 8, the bottom of 4, and this is what we want to find. So Pythagorean theorem, x squared is equal to 8 squared plus 4 squared. 64 plus 16 equals the x squared. X squared is equal to your 80. Root it. What goes in there? 16 and 5. So what do you get? You get 4 root 5. So we got the altitude. We know the lateral edge is equal to 4 root 5. And now we need the diagonal to the base. Well, what is it? We know it's a square base. Each side has a length of 8, we figured out. So we could either do Pythagorean theorem or have learned from yesterday that a square breaks up into a 45, 45, 90, where these sides are both x and the diagonal is x root 2. So that means that the diagonal is equal to 8 root 2. Awesome, huh? So much quicker that way. So there's your 3 answers. There's our lesson on 3-dimensional figures using Pythagorean theorem and 30, 60, 90s. Hopefully ended up well for you. Have a good one. As Winnie the Pooh says, ta-ta for now.